I hope you all are good and you all are practicing problems. Let us for now focus on this question. So, what is said in here? There is a ball of radius r having uniformly distributed volume charge q on it. Okay? So, what is given here? There is a ball, and in the volume of this ball, there is a plus q charge uniformly distributed. Nothing is said about it is conducting or non-conducting, but since charge is present in the volume, we will say that this is a non-conducting sphere. Why we are calling it non-conducting? क्योंकि अगर ये conducting होता, then charge won't stay in the volume. It will go onto the surface. Again, why? Because inside conductor, electric field cannot be non-zero. Electric field will be zero. And to make sure that electric field is zero, you cannot retain any charge in the volume. That I will that we can easily prove using using Gauss law. So let's do that. Let's say this is conductor, and let's say there is a positive charge in the volume, let's say. So let us now talk about calculating electric field at any position vector r. So we know that Gaussian surface for this point, we can draw it like this. This will be the Gaussian surface, okay? And if you write the expression for Gaussian surface, it will be how much? E dot ds is equal to q enclosed by epsilon naught. And since if charge is inside the volume, then Q enclosed won't be zero, because inside this Gaussian surface, you can see certain volume of charge, right? So Q enclosed is not zero. And if this RHS is not zero, LHS won't also be zero. So in this case, electric field will become non-zero. But the fact is, electric field inside conductor is zero. It cannot be non-zero. And that is why to maintain that status, Q enclosed has to be zero. That is, no charge has to stay inside the volume. Done it? So this is a non-conducting solid sphere having charge plus q. Now we are talking about, there is also given one thing. There is a spherical cell of radius small r having uniformly distributed surface charge q on it. So this is this, and this has a plus charge distributed uniformly on its surface. Okay? Done it? So these things are given. Its radius is also small r, and its radius is also what? Small r. Over. What else is said? The two spheres are far apart. Let's say separation between these two spheres is y. So y tends to infinity almost. Okay. Now what is said in A? A point charge q is moved slowly from the center of the cell. Let's say its center is C1, and let's say its center is C2. So from C1, a small charge q starts from here, and with the help of cavity in here, and with the help of cavity in here, it is able to reach to the point C2. Okay. And then we have to talk about work done by the external agent in the process. So how we can how we can calculate work done. So work done per unit charge, हमने कुछ ऐसा पढ़ा है, change in potential difference. Can we use this over here? So we can easily use it. क्योंकि देखो electric field के अंदर ये movement हो रहा है. Under the influence of electric field, this small charge q movement is happening from C1 to C2. And electric field is a conservative field. And conservative field में work done doesn't depend on the trajectory. It simply depends on initial and the final position. So if we know what is the potential of initial point and what is the potential of final point, we can calculate potential difference, and then we can calculate work done. Okay, so let us look at this thing. Let us say this is C1, this is C2. Then what is the potential at C1? So potential at C1 क्या होगा? देखो यहाँ पे बॉल का इन्फ्लुएंस यहाँ पे जीरो होगा, क्योंकि this is at infinite these two balls are at infinite separation. One is solid ball, another is cell sort of ball, right? So they are at infinite separation. So इसकी वजह से अगर आप यहाँ पे potential निकालते हो, then that will be kq by infinity, which will be zero. So at C1, potential will be only because of this spherical cell. And cell के लिए आपने पढ़ा है, अगर उस पे charge q है, then potential at any inside point will be equal to kq by radius. ठीक है? So potential at C1 will be kq by radius. Now what will be the potential at C2? It will be how much? Again, similarly, we can say that because of this cell, there won't be any potential at C2. Potential at C2 will be purely because of charge on this ball. Okay. So, ये आप कितना लिखने वाले हो? You should remember the formula that for non-conducting sphere, if we talk about potential at any inside point, then formula is what? V equal to kq by 2 रेडियस का क्यूब into 3 radius का square minus that concerned point. So let's say that is x का square. So at any point which is at a distance of x from the center, potential will be this much. Okay. And here C2 point is where it is at the center. So basically x is 0. अगर आप x को 0 करते हो, this will become how much? 3kq by 2r. Okay. So this is how much? 3kq by 2r. Now what will be the potential difference? So potential difference कितना होगा? 3kq by 2r minus this is your kq by r. So इसको आप 2 कर लो. So this will become how much? kq by 2r. This will be the value of delta v. So what will be the work done? Work done is q into delta v. So that will be your kqq by 2r. This is going to be your answer. Okay. Now let us look at the second part. In the second part, what is said, the two spheres are brought closer so that their separation or their centers are separated by 4r. Okay. So now they are they are brought closer such that distance between C1 and C2 is becoming how much? It is 4r. Okay. Now calculate the amount of work needed in slowly moving a point charge q from center of cell to the center of ball. So slowly we are moving, meaning we are not changing its एक्सटर्नल. देखो यहाँ पे एक चीज और मुझे फोकस करना चाहिए, दैट आई विल डू इन दिस पार्ट. ओके, सो यू डोंट नीड टू वरी अबाउट. नाउ कैलकुलेट द अमाउंट ऑफ वर्क डन इन स्लोली मूविंग अ पॉइंट चार्ज q from the center of cell to the center of the ball. Then assume that charge on one ball does not alter the charge distribution of the other. So इस टाइम क्या है तुम्हारा, दोनों ही बॉल 4 hour separation पे है, but it is said that charge on one ball is not going to affect charge distribution on the other. So charge distribution stays unaffected. अब यहाँ पे देखो फिर से कह रहा है कि चार्ज को, क्यू चार्ज को अगर यहाँ से यहाँ ले जाना है such that you are slowly taking it. You are not accelerating it. So slowly ले जाने का क्या मतलब है, हर पॉइंट पे इस पे इलेक्ट्रिक फील्ड लग रहा है. सो लेट्स से क्यू चार्ज है, इस पे इलेक्ट्रिक फील्ड किधर फोर्स लगाएगा, इन द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड. सो लेट्स से इधर फोर्स लगा, देन एक्सटर्नल फोर्स विल एक्ट इन सच अ वे that it will balance at each point the electric force acting. Done it? So we can say that whatever work is getting done by electric force will be equal to the external force. और इसलिए मैंने यहाँ पे ये फॉर्मूला यूज किया, डेल्टा V is equal to work done per unit charge. ठीक है, because this one you must have derived for the case where external force was equal to electrostatic force. और उसके कहने का मतलब ये भी है कि you were taking that charge slowly from one position to another, and that is why we are using it. Okay, so let us use it now. Again देखो concept सेम ही है, पोटेंशियल हमें निकालना है. So अभी V C1 का वैल्यू क्या होगा बताओ. Potential because of charge on its own surface, it will be kq by r, and because of charge on this one, it will be how much? It is at a distance of 4r, so kq by 4r. So this is going to be how much? This is going to be 5 kq by 4r, right? And what will be the Vc2? So Vc2 will be equal to because of charge inside its volume, it was how much? देखो अभी अभी हमने निकाला था 3kq by 2r. ठीक है, so यहाँ पे आप लिखो 3kq by 2r, and because of charge on this cell it will be how much? kq by 4r. ठीक है, so यहाँ से 2 को multiply कर दो, so this will become 6, and this will become how much? 7kq by 4r. Now what is the potential difference here? So potential difference अगर आप निकालो तो 2kq by 4r. What is the work done here? Q into potential difference. So 2kq into q by 4r. So this is going to be your answer. What will be this one? kq by 2r. Same as before we are getting, right? देखो kq by 2r, and this is kq by 2r. क्यों सेम आया? क्योंकि देखो दोनों ही केस में VC1 के साथ what got added? This one. And VC2 के साथ क्या add हुआ? This one. So difference is going to be same. We don't need to calculate it. In fact, answer will be same. It is not going to get affected. Okay. So I hope you have understood this part. But if you have any doubt anywhere, you can always let me know in the comment section. Thank you. Take care of yourself. Bye bye.